Okay, welcome to 3.8 Linear Quadratic Systems. In this we're going to learn how to solve problems involving the intersection of a linear and a quadratic function. So warm up, so we're looking at solving the following equation. And so you can try to solve this equation yourself. This is nothing really new, the skills that we're going to need here. We're just really interpreting what solving this equation means. Okay. So if we move everything to the other side, so I just grouped the 5x and the 4x at the same time, and the negative 7 and the 5 at the same time. So you could just put them under the 5x and under the 7, so you're grouping them at the same time. Then we get standard form, negative 0 equals 3x squared plus x minus 2. Remember, that's the goal whenever you're solving an equation involving a quadratic, is to get 0 on one side. That enables you to either factor it or use the quadratic formula. This guy actually does factor, 3x minus 2 and x plus 1. Remember, you can check it, 3x squared, certainly negative 2 is is the last number, and then the middle number is a positive 3x minus 2x to get 1x. And you solve each of the equations for 0, so the first bracket becomes 0 if x equals 2/3, and the second bracket would become 0 if x equals negative 1. We don't ever want to get caught up in memorizing that it's the opposite sign or something like that. Always remember that to get 0, we're trying to figure out what makes this bracket 0. So we get two answers. So the question really is, what do these two answers actually mean graphically? And so if you kind of guess, like we're looking at linear and quadratic systems, what these two solutions mean are these are the x values where the line is equal to the quadratic. So if we look at the graph, if we look at the line and the quadratic, the blue line and the quadratic parabola, the red parabola, x equals negative 1 is where they intersect, and x equals 2/3 is where they intersect. I'd ask you, like, where do you think you'd get the negative 9 from? Or where do you get the negative 2.33 from? So in fact, if you take x equals 2/3 and sub it in to either one of these sides, either the line or the quadratic, you will get negative 9, or you will get negative 2.33. So the question now is, what happens if we graph a line and a parabola on the same set of axes? There are actually three cases here, and it's very similar to what we talked about before, and you can imagine the discriminant is going to play a role in here. So option 1 is they intersect twice. So we get a quadratic here, and we get a line, and so what happens is, like, the line is actually going to hit the quadratic twice. Option 2 is they don't intersect at all. So you've just got a line that goes straight over the quadratic, and they don't intersect. And option 3 is they intersect once. So there's one point that the line touches the quadratic, but then it doesn't actually go through it. It just touches it, and what we call this is actually the tangent to the parabola. This is actually what we do when we study calculus. Throughout high school, we actually get these little tidbits of little hints of what calculus might mean. We started in grade 9 where we started talking about slope and speeds. And then here's another big time where we see calculus, and it doesn't have to be a parabola, but any curve, if you have a line that touches it just once, what we refer to this as really the speed of the parabola, or the speed of the curve. And so the speed of this curve, you can see, is positive. It's going up. And so the slope of that line actually tells you how fast the parabola is going. I think you can understand if a ball is being thrown in the air, that, like, it has momentum from throwing it up, and then it slows down height-wise, and till it reaches a speed of 0, and then it actually speeds up as gravity pulls it back down to the ground. So gravity will slow it down, and then gravity will pull it down faster and faster. And so what this line actually is the speed of the curve. So that we will do, like, you will learn more in calculus, but for now, like, we're just looking at it as the intersection of the parabola and the line once. So here's a question you can try. You can pause the video and try this on your own. So we're just trying to find the point of intersection of the two functions. So we asked the question, where does f of x equal g of x? And so we can just set them equal to each other. We have an equation very similar to what we had in the warm-up. If we move everything to the other side, we get 0 equals x squared plus 4x. This actually factors relatively easily. Like a lot of students miss this because they don't really recognize this. We don't see a lot of examples where there's two things. But remember that this is just common factoring. We common factor out the x, and we're left with x plus 4. And so we ask ourselves what two values for x will give us 0. And those are going to be the two intersection points. And so for this guy, it's x when x equals 0. And for this guy, it's when x equals minus 4. If we take that 0 and sub it back in, the easiest place to sub it in is to the line, to f of x. You can also sub it in for g of x, you'll get the same thing. And you get when x equals 0, y equals 4. So you get the point 0, 4. Similarly, if you sub in negative 4, you get y equals negative 4. And so when x equals negative 4, y equals negative 4. So you've got really 2 points of intersection, 0, 4, and negative 4, negative 4. And this is exactly what it looks like. So if you've got the line 2x plus 4 and the quadratic x squared plus 6x plus 4, these are the 2 points where it's intersecting. Okay? So you can try these questions as practice.